Well, welcome back. I'm glad to see you could make it again. I just got done removing the old wires and the old solder, extracting it using my old Hacko solder extractor. This little baby here really came in handy. All I had to do was just heat down in there. When it all melted, I could remove the wire and then hit the switch, and the old solder would just come right off of those tube pin contacts. Anyway, I went ahead and removed it all. And now what I have to do is connect a wire to all four of these to include this wire right here from our choke. Now let me remind you what we're doing by looking at the old schematic here. We're going to hook the two green wires to pin 1 and 4. We're going to hook the two red wires to pin 2 and 3. And then we're going to hook one wire from the choke over to pin 1. Okay? So let's see what we got here. Here's my two green and my two red, and here's my choke wire. Now, the question is, what pins are what on this, tube? Over here, we knew we had them all counted out. We figured out how they, which one was which on these other tube sockets. But this is a 4-pin socket. It is your rectifier socket. So which is which? How do I know which is 1, 2, 3, and 4? Well, let's take a look at the computer first. The computer is our friend. The internet is such a good buddy to us radio recipe stores. You really got to give it credit to the old timers who were restoring these radios long before the internet came around. I mean, I don't know how they did it. They couldn't just go online and order capacitors, and yeah, you could get them at the store and everything, but sometimes it wasn't so easy, especially if they had a rare radio. When they were learning how to do this stuff, there was really no one to talk to unless they went downtown and found a repairman and he was willing to be your buddy. And they had to study, and they had to take all these these mail order National Radio Institute courses to learn how to do these old electronic things. We have it all at our fingertips now. We hit a couple of keyboard keys and we're in business, Well, here's a 4-pin socket, just like the one we've got. And as you can see, 1, 2, 3, 4. The key being between the two large holes. That's the key. The one on the left is 1, and then 2, 3, and 4. So let's go to the top of the chassis and find out which one on our socket, which two on our socket are the large holes. There's our 80 tube socket, looking at it from the top, and you can see that these two holes here are larger in diameter than these two holes here. So these are the two holes that tell us where the key is, right here. So as I tip this thing up, these two will be at the top. See, if I tip up the chassis, they will be at the top. Okay? There we go. Now the top of the socket is the key. All right? Get a focus here for you. So there we go. That's the key right there. We'll go ahead and put a pencil mark on there. So counting clockwise, we have 1, 2, 3, and 4. So, we can even mark it here. There's nothing that says you can't mark that. This is your radio. If you want to mark it to make life easier, you can put a 1. You can put a 2 down here. Pencil, no biggie. No one's going to see it anyway. You can put a 3 over here. Some people frown on this kind of thing, but I don't care. I don't frown on it at all. And we'll make this last one right here. This pencil's really causing it to get blurry on you. There we go. We can make this one number 4. There we go. Okay, all 4 of the pins have been marked. Now we'll go ahead and connect up our green and our red to the pins that they need to go to. One other thing before I shut down and do the soldering, this is the wire coming from the choke. This was the original wire. It's shorter than the other one, as you can see, but unfortunately it will no longer reach pin 1 where it needs to go. So I'm going to have to splice a black wire onto it, which I had here just a second ago. Where did she go? Well, where did she go? Well, shucks. It was here just a second ago. I don't know what I did with it. Alright, we'll find it. Anyway, I'm going to have to splice a wire on this, and as you can see, that wire, I want to get really down close here. I want you to see this. Come on. Doesn't want to focus in on it. Back up a little, maybe it'll focus that way. No, it just doesn't want to focus on a wire that thin. Anyway, that wire is black, as you can see. That's tarnish. I need to tin that wire in order to splice another black one on there so it'll reach the socket. That tarnish will keep that solder from adhering to the wire. So I need to take my pocket knife and I'm going to lightly scrape. Let me open up my knife here. Alright. What I'm going to do is I'm going to lightly scrape right here, all the way around it. Try to get a little bit of a shine all the way around this puppy. And if I can get a little bit of a shine, now you don't want to scrape hard. Don't scrape hard. You don't want to be breaking any strands of that wire. You know, if there's 5 strands in that wire and it's handling high voltage and you break one of them, you're 20% down on the current handling capability of that wire. One strand out of 5, 20% reduction in the current handling capability of the wire. Don't, a lot of people say, well, I got 3 strands left, I'll just solder it up. Wrong, wrong, wrong. Do things right. You need all the strands that was originally in that wire. And I think this is a 5-strand wire. So I want 5 strands soldered to the splice that I put on. So let me see if I can clean it up a little bit. Alright, I got a little bit of shine going there. I very, very lightly scraped it, and then I took my alcohol brush with alcohol and gave it a good cleaning. Really worked at it. I supported it with my finger like that while I stroked it with the brush, cleaned it with the brush. Don't just let it hang there while you're doing it. So give it support with one hand while you clean with the other, and that means around the back and all that stuff. And I found my splice wire that I had set up, and of course I'm going to be splicing it on with the little old coil. My like of using coils, especially for splicing, and that works really well. I'll just slide it up there like that and solder it, and then I'll go ahead and put a piece of heat shrink over the top, black heat shrink if I got the right size. Remember now, you have to tin this wire first. Tin the wire. Put this over. This is solid wire, so I don't have to worry too much about the tinning. And then slide that over the top and solder it on. I asked my mentor, Brendan, my electronics mentor, I asked him one time, I said, have you ever sat at your workbench and never left the chair, sat there for an hour or two, never left the chair, never went anywhere, but you lost something you were working with? And there's no way it could go anywhere because you never left. He told me it happens to him every day. Unfortunately, I still have not heard from Brendan. I guess he's just flat down for the count. I guess that's all I can say. All right, let's go ahead and get this splice on here, okay? All right, one more time. I'm going to beat you to death with detail. I'm going to keep going over and over, so folks, don't forget. So this is kind of a reminder. We know that the pins are numbered, clockwise, 1 through 4, and we know which is which. Now the next question is, how do we know that the plates are pin 2 and 3 and the filament is 1 and 4? Before we hook up the red wires and the green wires, we want to make sure we're hooking them to the, we want to make sure that the red does in fact go to 2 and 3, and the green does in fact go to 1 and 4, not the other way around. So how do we know that? Well, back to our internet. Now here's Frank's electron tubes, which you will find on the internet. And as you can see, the plates for this is the 80 rectifier, full wave rectifier tube. 2 and 3 of the plates, 1 and 4 are the filament. Okay? Okay. The rectifier is now connected. We have the green wires connected to pin 1 and 4, and the red wires, which are the high voltage wires, the plates, connected to pins 2 and 3. And I also have one side of the choke, this wire right here. I've got some heat shrink on it where I had to splice that piece on. I've got it connected over here to pin 1. Now on the schematic, that would be over here, this side of the choke, over here, down here to pin 1. So now that's all soldered up, so we can put more orange in. Well, we're just really closing in on this thing, really closing in. We're going to go ahead and put some more orange in there. Good stuff. All right, one more wire. I'm going to take a break after this, and we'll come back at it maybe later. We got one more wire, which is the other side of the choke. Now, it wasn't long enough, and again, I had to splice some. Nice black solid. I use solid wire for this, and I've got to take the old heat shrink, put the heat shrink to it later. But right now, I'm not going to worry about it. It's plenty long enough to do what I want. Let's take a look at the other side of that choke. Where does it go? I decided to do a little change up here. Let's take a look at this wire coming from the right-hand side of the choke. Now it goes south, of course, and it goes down around this capacitor that's in parallel with the choke, and it also goes north. And it goes all the way up to right there. Let me zoom in just a little. How many wires do you see there? You know, where the connection is made. You see 2 wires? That's right. There's 3, and I'm going to tell you what those 3 wires are. Now, this is where the fun part. This is kind of a little tricky deal here, that if you're not experienced, then you can come up here. You're going to be looking for 2 wires, when in fact there's going to be 3. You have 1 wire coming from the switch. That's 1 wire. You have 1 wire coming from the coil. And then, of course, you have your wire coming from the choke. That's a 3-wire junction right there, folks. 3 wires, even though it only looks like 2. Keep that in mind. So what we have to do here is we have to determine this wire here is on one side of the switch, goes up into the coil to a trimmer cap or a patter, whatever you want to call it. The other wire comes out from the switch and connects to the coil right here. It'll be our junction. So what I need to do is I need to find out the wire coming from here. I need to find out if that wire is for, in fact, pin 2. Let's go down and take a look at it, and we'll figure this out. Now what we've got here is our switch is right here. Our switch is right there. Now we've got 1 wire that runs up into the T2. It's a factory solder job right there, okay? It's not been touched. It just goes on up into T2. Now that wire is, if I get this thing back in here, yeah, okay, that wire is this wire right here off the switch. Goes up into the trimmer, okay? That just leaves us a 2nd wire coming out. Let's see if we can find that one. The 2nd wire coming out is, this is the one going up in there. The 2nd wire coming out is this one right here, okay, just hanging. What we need to do is test between pin 2, let me go back to our schematics so you know what I'm doing here. We need to test between pin 2 of the first detector right here to that wire you saw dangling, and make sure that's the correct wire. This should run, we should get continuity from that wire that's dangling to pin 2, the plate on this first detector. Now I don't know if this is the way it was done at the factory or not. It sure looks factory. The way they connected it, they connected the switch wire, this dangling switch wire, they connected it to this one here, the dangling wire coming out of the transformer. And then they took the choke wire and they stripped a piece of the wire and just, wrapped the choke wire around it and soldered it there. Holy mackerel, talk about tacky. We're not going to do that kind of stuff. You know why? Because we're better than that. Yes, we are. We're going to connect it to this terminal strip right here. Okay, let me zoom in there. we're gonna take this wire right here. Now this is going to be a temporary tack solder, because when we're all done, we're going to be changing out a lot of wires in this chassis and repositioning them and rerunning them this way and that way. But first we want to make sure the radio is functional. Then we can do all that, okay? So this wire from the switch will come over here and connect to, oh, it'll probably go on either this terminal right here or this terminal up here. I haven't quite made up my mind yet. Probably this one, okay? We'll just put it right there. I could even move it down a little further and put it on the bottom one. That way it'll leave a lot more free. Then I would take this little wire right here and I'm going to cut it. It's too long. As a matter of fact, I'm going to cut it right now. God, I love cutting wires. Jeez, look at this. Oh, it's done. It's done, Martha. And I'm going to go ahead and take that wire, bend a little hook, and I'm going to run it into the same terminal that the wire from the switch is in. Then I'm going to take, let me get my little needle nose here. I've already run the choke wire all the way through, close to the chassis, all the way across, and got it over to this area here where I thought it would need to be, positioned. And sure enough, there it is. There's the end of it right there. I'm going to take that, and I'm also going to hook it up to that terminal with the other two wires, and we're going to solder that together, just like that. Okay? So let's get all three of those wires soldered to that terminal, which means I may have to shorten this one up a little bit, kind of dress it up a little bit, even though we're going to just tack solder it. You want to try to do your best each time, but you want to be careful on these coil wires. Don't be cutting them too short. If you do, you're going to be up in that coil. Have to tear that coil apart to figure out how to make it longer. We don't need that, okay? Well, let me go ahead and get it soldered. Okay, folks, we have it all soldered up. It's looking real nice and good, nice and solid. Kind of give a tug on these wires. These wires are tarnished, even though they're solid sometimes. You got to kind of make sure you got a good solid connection, good mechanical connection all the way around to include that brand new wire, which is the, all right, everything is nice and secure. That brand new wire down there, which comes from the choke. All right, that is done. Now, I have some fun for you. For the last several weeks, I'll tell you what, before we do anything, let's put our orange in. Ooh, we got to do our orange. Yes, our orange. Let me get my orange pen out here. All right. What have we done? Oh, what have we done? We have run the wire from the choke all the way down, all the way up and all the way down. That wire is now in all the way across. Look at that. Ooh, this is too much. All right. I think we're done. All the way down to the choke. All right. Now, where was I? Oh, yeah. For the last several weeks, I have been spoon feeding everybody. This wire goes there, and this wire goes there, and follow it to here. Well, I'll tell you what. It's time for you to stand up and be counted. It's time for you to do your own sleuthing for a change, and I'm going to give you a chance to do it. Let's take a look at the bottom of this chassis. Now, I don't want any comments added to this YouTube video telling me what you think the answer is. I don't want that. I want you to just keep the answer to yourself, and then in the next video, I'll give you the answer, and then you can say, yeah, I got it. Or you can say, well, I blew that one. Anybody that puts the answer down, I'm going to delete the comment, okay? So don't even waste your time or mine. What I have here is a wire. I want you to take a look at this. I want you to take, right here, now this is the 47 tube. See, I got 47 written practically everywhere. And I have a wire that runs from there down to this right here. Tell me why that wire runs from that particular pin down to here. Here's a snapshot of the section of the schematic that'll give you all the help you need. But if it's not enough, you can always go to nostalgiaair.org and, go ahead and print out a copy of the schematic and study it that way. You will need another slow scan of the top of the chassis. Alright, that's what the top of the chassis looks like. So let's see what you got. Let's find out if you've learned anything, or do I have to continually spoon feed you some more? Until next time, this is John. Time for a little update on the old FM transmitter. I haven't forgotten it. I have been, piddling around with it. I've got it working good now. I had to remove this antenna, this big old metal antenna, this extendable antenna. It just didn't work. It just didn't work. So I went ahead with a straight wire. And a couple of mishmash videos ago, for those of you who watch my videos, I was standing out the other side of my garden and picking up the FM transmission of Sergeant Preston of the Yukon using this wire right here. And I also went ahead and realized that this wall wart that I was using, this 9-volt wall wart that I was using for power, plugged in the side here, like that, was also causing a lot of my problems. It made all kinds of noise, and the transmitter just wouldn't work. So I got rid of this and that. Lesson learned on that, guys. And I took a regular 9-volt battery, and I went ahead and opened it up, and I alligator clipped it in here where it goes to provide power. It worked really well, as you saw in the video. But that, I just couldn't stop there. I had to do something. I didn't want those alligator wires to go inside, leave the box half open all the time like this. With the battery outside laying on the table or something. That was just kind of tacky. Anyway, I came up with a brilliant idea. Oh, a brilliant idea. I just love my brilliant ideas. Sometimes they turn out not to be so brilliant. Anyway, I decided, if I could find... Now, this is a double A... No, what is this thing? This is a C-cell battery holder. And I'm thinking, if I could find a 9-volt battery holder, that I could just put the 9-volt battery in it and then fasten it, to the side here somewhere, maybe to the rear, like that, with a wire that came around and had the same kind of plug on the end that this wall wart had. Maybe I could, find it and just put a wire on myself, cut the end of the wall wart off and splice it onto the wires and then just plug it in and use it that way. Maybe that would work pretty good. And I got thinking, I said, I wonder. I went on eBay and I started looking around, and guess what I found? Exactly what had come up in my mind. The 9-volt battery pack with the wall wart connector on the end. Is that too cool or what? So let's go ahead and open this baby up. By the way, it cost me all the way from China. It cost me $1.25 total cost. Is that amazing? And let me tell you the best part. It has an on-off switch. Look at that. Come on. I was amazed when I found that thing. So we'll go ahead and put our battery inside. And this thing here is exact. I took a chance on the exact fit. It does fit just right. Let me get this up like that. Look at that. Plugs right in. And all I've got to do is come up with a little Velcro or something, and maybe fasten it to the rear like that. And that way I can continue to, to open the lid without having to unplug the box. Is that cool or is that cool? And I'll give you a little demo in a future video to show you how it all works.